Good day, students. I do hope that every one of you is safe and doing great. Welcome to my class. Today's session, we will be tackling on waves, particularly the nature of the waves and its types. So it will be a brief discussion on the basic concepts that we must know as we go through our physics subject. But before that, let me first present to you our learning objectives. At the end of this short discussion, you, students, are expected to attain the following. First, you should be able to describe a wave and distinguish its types. Second, infer the difference between transverse and longitudinal waves. And lastly, cite examples of both types of mechanical waves. Disturbances in matter. So matter, as we know, are composed of particles or molecules that are in motion. And most of the energy needed to be transported should pass through a matter or any media. Disturbance of these molecules of either solids, liquids, and gases, and even in a vacuum, create an oscillatory movement which carries energy that we referred as waves. Say for instance, when we strum the strings of a guitar or any string instrument, vibrating string disturb air molecules, thus creating sound. When we throw stone into a pond or basin, ripples are created along the surface and is disturbed. The same is true to a digital clock or analog clocks that we have. The inner workings of the clock causes some vibration and produces buzzing sounds. On the gym, we can observe people hand pulling and making rope to a wave-like pattern. All of these images are depicting to one topic, which is waves. Given the idea on the previous slide, we can now therefore define what waves are. So wave is a disturbance in the medium that transmits energy without transferring the medium itself. The key word you must remember and understand is disturbance, because waves in simple context in physics are nothing but a disturbance that transmit energy. Disturbance produces oscillation. Note that waves carries energy and not matter, and that the disturbance traveled from one point to another or location to another location. So again, it transfers energy without transferring the medium itself, okay? So, waves are classified on the basis of the direction of vibrating particles and on the kind of medium to which it travels. Yes, waves could be classified according to first, the particle's movement along with the wave direction, and second is on the basis of the medium to which a wave can pass through. Again, there are two major types of waves, the mechanical waves and the non-mechanical waves or the electromagnetic waves. Under the mechanical wave, we have two divisions actually. However, a third type is considered to be a combination of the first two. But the main focus of my discussion to you for now is the mechanical wave. Let us discuss each thoroughly as we go through our succeeding slides. So first, we have the transverse waves as the first types of mechanical waves. So in this type, the oscillation is perpendicular to the direction of the wave's propagation. So take a look at the illustration below and notice the red dot or this red circle at the middle of that line. What can you say about its motion? That red dot represents the particles of the medium, and yes, the motion is to and fro or going up and down. Particles do not move along the wave, but the oscillation, as I've said, is upward and downward as the wave passes. So look at my presentation. The two-way arrow in a vertical orientation, or let's say the y-axis, as if we will look at it on a Cartesian plane, is the movement of particle and is displaced perpendicularly to the waves direction of energy or the wave's velocity, which is the horizontal line. Look at the GIF, horizontal line or the x-axis as you see it, making right angles or a 90-degree angle. So let's go deeper to its parts. So consider the diagram of a transverse waves. Transverse waves, as you can see, follows a sinusoidal waveforms, crest to crest and trough to trough. So where is it in the transverse waves illustration? So the middle line, this middle line is the equilibrium position or the rest position. Meaning, if particles are resting in this area, no disturbance is happening. From this rest position to points B, D, and F are the amplitudes of the waves. Amplitudes are defined as the highest or maximum point of vibrational displacement from the center line. It could be it could be the crest or the trough. Points B and F is the wavelength. As the term suggested, wavelength or length of the waves refers to the distance between crest to another crest and troughs to another trough. So assuming that the illustration is continuously extended from points D to right, let's say H could also be a wavelength from D. So if let's assume that this illustration is or wave illustration is continuously extended. So if we have this point D, the next point, let's say the point H, this could also be a wavelength. Next, from the center line down to point D, we called it as trough, which is the bottom or lowest part of the wave. Conversely, points B and F are the crest and are the peak or the top of the wave. Let's move on to another classification or types. So another categories of mechanical waves is the longitudinal waves. So let's see how it differs from the previous one. Slinky is the best representation of a longitudinal wave. Longitudinal waves is the complete opposite of the transverse in reference of particle motion. In contrast, longitudinal waves can be defined as a mechanical disturbance where the motion of the oscillating particles of the medium are the same as that of the direction of the wave's propagation. So meaning to say that both are in one direction or are parallel to each. Please see this motion picture presented to you. So what did you again observe as on the slinky as it moves? So you will notice that there were some points or areas from which the slinky is compressed and parts where the coil is spread apart and are expanded. And note that particles are moving side to side, backward rather, and forward, or from left to right as wave passes by. So same with transverse, let us identify its anatomy. So again, it's parallel, both the direction of the oscillating particle and the direction of or the velocity of the wave. The bidirectional arrow is again the movement of particles, the back and forth motion. The arrow going right side is the direction of wave. Both lies on the same orientation. So areas where the coils are compressed is the compression of longitudinal wave. It is in this area where there is higher pressure and the part where coils are at its farthest to each is not called expansion, although it in fact exhibit such, but the term we use is rarefaction. Wavelength, on the other hand, is the distance between either compression to another compression or rarefaction to another rarefaction. Example of this type of mechanical waves is the sound waves. So let's move on to the third type, the surface waves. So surface waves are in between the transversal and longitudinal. The oscillation follows an elliptical or circular path. It's a combination of the two. So observing the simple animation that the duck or the red dot on the other side, as every time a crest passes the movement of that is circular and it's a complete cycle. Is it still important for us to keep in mind that the molecules nor the duck in the visual does not move along the wave? So as you can see, they are just moving in an elliptical path. So seismic waves can either be transverse, longitudinal, and or surface waves. So in this discussion, you were acquainted about the fundamental concepts of waves, nature of the waves, and its classification. So it's just an introduction. A surface knowledge, I may say, for for future topics. So keep it in mind. So indeed, we had really attained our goals. So to wrap it up, here are the highlights of our discussion. So mechanical wave again needs material to pass through while EM waves does not need material. Transverse waves has a sinusoidal wave pattern and the motion of the waves particle is perpendicular. So some of its types are rope waves, water ripples, vibrating string instruments, or light waves. Longitudinal wave is a type of wave where both the wave propagation and particles motion are of the same direction. The sound waves, slinky are some of its best examples. So waves carries energy and not matter. So keep it in mind. Take note this. I will give emphasis to this. Waves carries energy and it doesn't transmit the medium but only travels on a medium like the mechanical wave. When there is a disturbance, there is a wave. If there are no disturbance, no oscillation at all, no wave. So a mechanical waves exhibits a simple harmonic motion or all of are the transverse waves and longitudinal waves, they are exhibiting a simple harmonic motion. So thank you for listening. I hope you learned well.